So good morning, everyone, and welcome to the EMBRC Technology webinars. I'm very glad today because we are launching our marine observation series. First of all, I want to warmly welcome people who register from such faraway places as New Zealand, the United States, and of course, our audience from all over Europe. While people are still joining, I would like to briefly present our organization. For those who are new to our community. So the European Marine Biological Research Center is a research infrastructure connecting more than 80 marine stations, universities, and research institutes established across 10 European countries. I invite you to check our brand new website, who was launched only 2 weeks ago, and browse through our catalog. Julie, if you can send us the link for our new website so our audience can check it out. Our new catalog has very nice features such as filters, descriptions, and like that you can dive into our more than 500 services that we offer to academia and private sector. Why are we doing this series on marine observation? Well, because EMBRC runs its landmark initiative, the European Marine Genomics Observatory, EMBRC, where we follow changes in biodiversity all through the European coastline from the Arctic to the Red Sea. But what is unique about this observatory? Well, it is that we have a calendar, we do periodic samplings from water columns and also from hard substrates. We use every time the exact same sampling procedures. We treat the samples in the same way, and also the data that comes out is treated in the same way. This ensures high quality of our data, the comparability of our results. Of course, they are reusable. We treat them, we work under the FAIR principles. And if you would like to know more about the protocols we use within our observatory, I invite you to check them out in the UN repository, Ocean Repository for Best Practices. I will ask Julie if she can put the link in the chat, please. And also, if you want to know more about the applications of this observatory, we have our last publication is on artificial reef monitoring systems under this EMBRC umbrella and its applications to identify invasive species. So through this European Genomics Observatory, we assemble a solid network of experts in ecology and marine observation. And this is why we want to spotlight in this webinar our colleague, Dr. Carmem Manes, originally from Brazil, where she made her studies in chemistry at the Federal University of Rio de Janeiro. Then she followed a PhD in biotechnology at the University of Ghent in Belgium. And Carmen developed then her career in France, where she has been working for 12 years with experience in eukaryotic cell division, environmental microbial diversity, and recently sensor development. This is a field of great interest to her for applications such as microbial risk assessment in industrial, but also in natural marine environments. And since 2019, she works at the BOSS. The BOSS is the Banyuls Observation Sea Service. We will put the link also in the chat. So here in the BOSS, Carmem works as a principal investigator in research and innovation projects aiming for the development of autonomous and automated instruments, allowing the collection, the pre-treatment, and the analysis of biological EOVs through eDNA in aquatic environments. Before giving the floor to Carmen, I just want to remind our audience that you can use the Q&A section and also vote for the questions that you like the most, so we give priority to them. So thank you very much for joining us, Carmen. The floor is yours. Carmen, you are muted.
I'm sorry. Thank you so much for this introduction and this opportunity. It's a great opportunity to talk about my lab, my team, and the work that we've been developing. So I'm going to share my slides, presentation. You see it? Can you see?
Yes, we see your slides, but not in the, we see your screen. We see your screen, not in the presenter. Now we see your screen.
Okay, so let's start. So thank you so much for this opportunity. As Mery told you, I'm a molecular biologist. I have a PhD in biotechnology, and I work since more than 20 years at the Banyuls Marine Station in south of France, Mediterranean coast. So today I'm going to talk about our project, which is called MicroSense, a step forward to a new platform for augmented ocean observation. So, as I said, I'm working in the lab for more than 20 years in several R&D and I projects for environmental observation at our study site, which is a unique terrestrial marine continuum in France. So our mission in the BOSS is to develop technology to better understand and preserve health of aquatic ecosystem by ensuring water quality. Everything and related, we are always focusing on high frequency acquisition for a better knowledge, to foster research, observation, R&D, and innovation research, education, and outreach. So our observatory network is linked to national and international surveillance networks, generating standard biogeochemical and physical data at various frequencies. For instance, the SUMLIT National Observatory covers 15 biogeochemical and physical parameters at weekly base. And the COST-HF, high frequency, coastal high frequency, covers few of those parameters online. And this observation is supported by a technological platform called HemiMed to give access to a high-frequency instrumented marine network services. So we have a fleet with 2 vessels and with crew and diving services. We have classical oceanographic instrumentation like ROV, Rosette, CTD, multi-parameter probes, etc. 2 oceanographic buoys, Sola and Poem, at our coast nearby. And we have a cabled network with an instrumented junction to test instruments underwater. We have also environmental instrumental system, which are developed by an R&D team with 6 engineers, which I belong. So I joined the platform in 2019, as Mery just said, to implement the environmental DNA, eDNA based surveillance at high frequency in the lab. As we know, it's not an easy task because although eDNA is the fastest growing biomonitoring tool, its broad use is still under several constraints, mainly related to a difficult access to environments to be monitored, which gives a high cost of sampling campaigns or even normal campaigns, which hinders the increased frequencies of this analysis because there are very long delays between sampling, the transport of samples to the lab, and the analysis. And to tackle these constraints, here, well, first of all, this is just an example for those who are not familiar with a classic procedure for a nucleic acid analysis from the environment. Comprehends the sampling, the pre-treatment of these samples, the treatment, analysis, and data transfer, which is highly costly. And our goal is to reduce these costs to be able to have a high frequency acquisition of these data. And for that, we developed two instruments. One is an environmental nucleic acid sampler. It's an autonomous system, I will explain later. And another one, it's also an autonomous ENA sensor. And this is the basis of the MicroSense technology. So to give you a background on this development, first we developed an ENA sensor, which is an autonomous genosensor for the genetic identification of target taxons. The instrument, it harbors an immunosandwich hybridization assay coupled to a colorimetric detection system. And at the end of the process, coloring intensity is proportional to sample target concentration. This has been validated and calibrated on waterborne pathogens as Vibrio and E. coli, and as well as for the toxic cyanobacteria microcystis. So this development was under different funding schemes. So we achieved in 2022 a proof of concept for this development. And now we have two programs that are being held to develop it further. So one, it's CNRS GDR-Homer thesis that began in 2023 to deal with the microfluidics and the miniaturization of this biosensor, and which is also sponsored by a maturation fund from the Society of Technology Transfer, SAT-LUTEC. Likewise, we have developed a nucleic acid sampler and extractor. So this sampler is able to collect, concentrate, and extract the environmental nucleic acid, both DNA and RNA. It is fully autonomous and teleoperated. And the first version, the V0, was validated for the detection of pathogens and viruses and overall diversity, biodiversity study through omics approach. So this sampler, it's able to deliver a ready-to-use ENA-enriched cell lysate for all-purpose analysis. So instead of going to the field and bringing lots of liters of water to the lab to be processed, we bring only a small tube containing few milliliters of an enriched cell lysate that can be used for many other downstream molecular analysis. So this is just an example of application. We had performed spatial temporal diversities of microbial communities in our solar observation site in summer 2023. We collect samples from subsurface and deep samples, so it's just 30 meters depth here. And we were able to have a temporal distribution of microbial communities in a weekly basis during 1 month. And this study was to compare with traditional sampling and concentration methods that we normally used in the lab. The MicroSense technology, it's the basis of the creation of a new platform for an automated augmented observatory. So the goal of MicroSense is to fuse these two instruments in one, to be able to have from sampling to data in one single experiment. So this will enable the investigation of spatial temporal dynamics of environmental nucleic acids for different biological targets and communities. We can whether install it in a fixed point observation, for instance, in a buoy, morning buoy, or platform, or a vessel, for instance, or we wish to integrate, this is the next step, to integrate the sampler in mobile vectors as ROVs, RUVs, or gliders. So this will allow the spatial temporal monitoring of biodiversity at high frequency in remote areas, to do transects integration of this information, the environmental nucleic acid data, with other biological descriptors. For instance, integrate this with high resolution imaging or underwater flow cytometry data. And also it will be important to monitor invasive species for modeling purposes. So this year we are going to integrate the environmental nucleic acid sampler into our SOLA station, which is an instrumented buoy. And we will perform a bi-weekly frequency sampling just to, as a demonstrator for a short period, 1 month or 1 or 2 months. The idea and our ambition is to deploy the e-platform in the 3 marine stations, which are part of the EMBRC France, and also to be able to deploy it in other marine stations afterwards in a long-term run. So we have performed for this development. As I said, we are accompanied by a society which is responsible for the technology transfer. And they performed with us a market study, which identified three main markets for the technology. Our technology meets the needs of microbiology, water testing, which is a strong need for automated monitoring tools. Also for the food and industrial waters to monitor, for instance, contamination, and they need for an on-site monitoring tool as well. And as I explained, for biomonitoring purposes as a whole, with environmental biosensor, in which they have a need for high frequency analysis as well. So how our technology distinguish from the others that are in the market today? So what is the added value of our technology? So today, the sampling for all the environmental DNA or RNA, it's made whether by manually using a small filter cartridge, everybody knows, Sterivex, or flat disc filters, or even more recently, there are these small cartridges that are processing a bigger volume. So, but these tools, they have a limited process volume due to their surface. So if we compare Sterivex with the cartridge from Watera, we see that they have only 10 square centimeters, and the one from Watera, 600 square centimeters. And of course, they all need to go to the field, bring water, or if we filter in the field itself, it's not an automated process. So for the automated, we have the DOT, this automated system that is now it's getting a lot of attention, but still they have a limited filtration area, just 5 square centimeters, which limit the volume that we are going to sample. And the Roxy from McLean, they use lots of Sterivex. However, they also have this limitation in the volume that they can process. Although these two instruments, they are very good and they perform everything autonomously. So our technology, our sampler, we have a tailored cartridge that has 5,000 square centimeters area, and we can process volumes of more than 50 liters if we want to, which allows us to go from detection from viruses to other eukaryotes. And the other advantage from our system is that the whole system is fully recyclable. So we can reuse and disinfect the cartridge and the whole fluidic system for another sampling procedure. And all the others that are mentioned in this chart, they are single-use filters. So what I would like there are some messages that we should consider, because there are many instrumentations being developed, but few are commercialized. So there is a reason for that. It's because it's a very complex system. We need to address many issues regarding regulatory compliance, data integrity and quality, validation, reporting. So it's not a straightforward work to commercialize such instruments. So there is also something that we must consider, because there is a difference between what the users want and what they really need to be done to answer to a problematic. And this is a balance that we have to reach. And also the question for adaptation, because new develops need to balance also the scientific curiosity, so discovery, and routine monitoring needs. So both can be combined, but the routine monitoring needs, they are more standardized, so we cannot make it that flexible. So this is something that that we have to keep in mind, to develop something that are reliable to track key indicators in a high frequency manner. So everything that I told is made by a team which is multidisciplinary and skilled and hyper-motivated people that work together since 2019. So Julia Baudard, she's associate professor at the Sorbonne University, and she's a specialist in environmental microbiology. She's also expert in biosensor and microbial ecology. Michel Groc, he's an engineer responsible for the service of information and communication from the lab, and he's an expert in automatization, communication, and interface on machine. Renaud Vullman, who is my boss, actually, and he's expert in instrument development, fluidic systems analysis, and high frequency in situ data acquisition. And myself and the team is joined recently by our PhD student, Eva Agranier, who is working on the microfluidics aspects of the biosensor. And Pierre Groc, who is a research engineer working on the aspects of automatization, and he's also an expert in sensors. And Alexis Cross, an engineer, he's working in the field of electronics of our developments. So just to finish, to give you an idea how this adventure started. We are not to the market yet, but I will give you our path, how we developed all those years. So we started in 2019, working together in different R&D and I projects. In 2022, we were accompanied since 2022. We are accompanied by the Society of Transfer Technology, and with their help, we performed a market study. We already filed 2 patents from both technologies, and we have a co-maturation. It's a joint maturation program with an industrial of the water microbiological tests that joined our maturation program, which will help us to achieve TRL 8 for the technology. This industrial partner was conquered by the technology and all the possibilities that will the added value that this technology will have for their work, for their field of business. And we are also accompanied, we received recently from the BPI France, which is a Banque Publique d'Investissement in France, a fellowship, which is called a French Tech Lab Bourse, which will help us for juridic and business development coaching. So that the technology will be ready to be transferred by 2027, and in 2028, the expansion for other markets for the technology. So as I said, the priority market for this technology is the one from microbiological tests, which is $15 million, and with an increase of 7.5% per year estimated. Yeah, the co-maturation, the joint maturation program will bring us to pre-industrialization of the technology, and possibly with a startup created or a technology transfer to an industrial in 2027. So that in 2028, we will have the technology on the market. So I think it is everything that I would like to tell you. I'll be so glad to answer your questions if I can. So don't hesitate. And I thank you so much for your attention.
Thank you very much, Carmem. So I don't know if there is any questions. Please add your question in the chat, and we can open your mic so you can ask directly to Carmem. We have a question now from Carl Lunden. Do you do nanopore sequencing inside?
Yeah, we are now being equipped with a nanopore technology, and this year, together with another platform, we will start doing nanopore on site.
Okay, thank you very
Definitely.
much. We will put Carmem Renault's contacts in the chat, so also you can you can contact them whenever you want. We have another question from Sophie. Maybe we can stop sharing the screen and we can ask Sophie to come to the floor so she can ask her question live and discuss with Carmem.
Just a moment. I lost you.
Okay, so I will start reading Sophie's question. For eDNA sampler, how many samples can it take during one deployment, and how long can it be deployed at sea?
Yeah, it's the last version is for 7 samples in series, and the time of deployment we have made some studies, but it's laboratory studies for conservation, and it's we can conserve, we can preservation, sorry, we can preserve the samples in until 30 degrees for 15 days. But this was just a preliminary test. We need now, with the deployment into the buoy, into the buoy, the observation buoy, we will have more precise information about preservation and time of deployment.
Okay, thank you, Carmem. So I hope Sophie's question was answered. If not, please let us know, Sophie. I have questions regarding the startup creation, because that is also one of the objectives of these webinars, to inspire people from our community and from outside. So I would like if you can share with us a little bit the importance of what is called the innovation ecosystem within the Banyuls, no? Because I know that you had a lot of exchanges with regional partners. So maybe you can share a little bit. That would be interesting.
Yeah, we have an incubator, startup incubator in Banyuls, which is now being affiliated with the one from Sorbonne University in Paris. So this is the ecosystem, the business ecosystem that startups can benefit. It's from all the accompaniment that this incubator have. So, but in our case, we anticipated these aspects of business development by applying for a French Tech Lab fellowship from the BPI France, which is really funding for to be coached by business developers, lawyers, designers, marketing people. So this is something, it's very useful. I don't know if in other countries this exists, but here in France we have this opportunity and we got it. But regional incubators also give this mentoring just if you inscribe. So we have here in Banyuls, but there is one also in Perpignan. There is in Montpellier a lot, or Toulouse. So regional incubators, they provide all this mentoring once you are accepted into their incubator.
Yeah, what I really liked about all the story when you told me the story of the of the sensor development is that that you interacted with other engineers that were in the region to develop like the filter and so forth. And I find this very particular and also one key for the fast advancement of the technology that you are developing.
It is. We were lucky to have technological platforms that are regional platforms, just very close by. And we use this. It was already a historical collaboration that we had with them. Every small prototyping or ideas, we were working with them for many years. And soon as we had these projects going on, we went there. So it's like a brainstorming. We bring our ideas and our cahier de charge, I don't know how, all the technical specifications of what we really want. And we exchange very openly with them. So it's really an emulation of knowledge that is very how say it, it's very good for the development and also to open our ideas, because sometimes we are kind of far from what are the newest technology or the pieces or the small parts that we can put in our system to have a better performance. So this was very interesting and very nice for us.
Yeah, I think this is a key for innovation, the multidisciplinarity and the close exchanges. So that's very nice to see an example here. So we have another question from Frédéric Perret. Could you develop on the method you are using to monitor NA amplification in real time, which colorimetry, detection only, and or quantification? So we are opening the mic of Frédéric. Maybe like that you can discuss directly also.
Yes.
Yeah, hi everyone. Yeah. Hi Carmen. Can you hear me well?
Yes.
Yeah, all right. So I had this question because I could see in the presentation some blue colors that was basically translating for the nucleic acid amplification. So I was just wondering, which is this method? Was my first question. The second one is that, do you do detection only or can you do quantification? That was the second. And can you adapt to your existing instrument other method to follow nucleic acid amplification? So that's fluorescence-based like RPA or LAMP method for nucleic acid amplification.
Very good questions. Yes, in the biosensor that we developed, it's not an amplification, but it's more a concentration of the target that we have. So what we do, it's a sandwich hybridization method. And what we hybridize, the specific probes that we have, is the signal that we have. So all the method is calibrated with cultures and spiked natural samples, so that it's a semi-quantitative data that we have at the end. So it's a sandwich hybridization coupled with an ELISA immunoassay. So at the end, we will have a redox reaction that will give colorimetric reaction at the end. So we can infer the intensity of the color through to the concentration of your target in your sample. The sample that it's not an amplification, it's not a PCR, it's not a LAMP. However, going to your second question, it is what we built was a kind of analytical core that we had this detection for ELISA, for instance, and to do the sandwich hybridization, all the steps to perform this analysis. But we can also apply for LAMP or for in situ PCR. This is completely feasible and adaptable, but we still didn't have personnel or fundings to further develop these other aspects of the core analytical system that we have.
Okay, I see. So and is everything going on at running at room temperature, or do you need to heat a bit the reaction? I mean, how
yeah, we have heaters. We have a way to heat the samples or the reaction chamber, and to keep all the reagents at refrigerated. So it's a very complex analytical system, but everything is provided.
Okay, thank you very much.
Welcome.
Thank you very much, Frederic. So we have another question from somebody in the attendees. It's Panagiotis Kasapidis, who has raised his hand. So we will try to unmute him.
Okay.
Hello.
Hello. Yes, I rather raised it by mistake, but anyway, I have a question.
Yes.
I see that these methods in situ, they are mostly for single species detection, or you can adapt somehow in situ to have data for the whole community for DNA double coding, for example, for fish or for other organisms. How far we are from this situation, because it's easier, of course, for single species, but when we go to the whole communities, it becomes more complicated.
Yes, for now, at the state of the development that we have, for other targets, we do barcoding at the lab. So this is it's another. So we take the samples that comes from the sampler and the lysate, and then we further process as a normal sample for barcode uses. However, the biosensor can be adapted for single species or for genera or families, provided that the probes that are hybridizing, the probes that are meant to identify your targets are specific enough. So if you have specific probes, we can adapt into the biosensor.
One more question: how much time does it take to filter water with your equipment? Because, for example, I know with Watera, which is, as you said, a big filter, it takes in the oligotrophic waters of Greece, we need at least around 1 hour for 50 or 60 liters, 1 liter per minute to filter. So I don't know, because also this can be constrained, how much water and how fast you can filter water.
It will be the same thing, because what we want, it's not hyper fast filtration, because it can also affect the cells and DNA, and we can lose information within the process. So, however, we can set up different speeds, filtration speed, but of course the limitation is the pump itself that we use, and it will be at the same order as the one from Watera.
Thank you very much.
Welcome.
Thank you very much. So we have another question, and I would like to see if maybe Philippe wants to join also the discussion. because I think his question is more for discussing, because he wants to know how long have you been working with this technology, how effective is it? He wants to know already the name and the machine and the costs. So
yeah.
So maybe Philippe, do you want to say something else, or? Okay, maybe you can answer, Carmem, in the time that Philippe.
Actually, it's not yet a finished product. As I showed you, there are lots of still things to do about design and security compliances. So it's really a long process from now. But what we have is still a prototype, and we can't give a value for that because it's made in a very small series to comply with the needs of our research projects, for instance. And we are not capable to industrialize or to build others like series of 10s or 50. So all this also have an impact of the final cost of the product and the market price of the product. So I can't give you, but it won't be what our idea at the very beginning was to make it very democratic instrument, because we know that everything that is related to marine, for instance, observation, it's really costly because there are lots of, it's a harsh environment, and compared to continental waters. So because we have to deal with several aspects that are different when we work in continental waters. But the idea is to have something that is affordable so that many people can have one and start producing data at high frequency so that we can really make a difference in aquatic monitoring for water quality purpose or biodiversity surveys, any other applications that we can imagine.
Okay, thank you, Carmen. I don't know if Philippe wants to add something else to his question. We have tried to unmute him, but it's not working. Maybe something that that I would like to add to Philippe's question is I don't know, Carmen, if at the stage in which you are of the development of this prototype, if you are looking for some specific type of collaboration or investment support or something that you would like to engage some kind of stakeholder, for example?
Mm-hmm. Yes, I mentioned that we have this joint maturation program going on with an industrial partner, which is #1 in France with all the microbiological analysis. And this will help us a lot because we will have real case studies with their own clients on site, and this is fundamental to have a feedback and to be able to pursue the development or adaptations that must be done after these real case studies are finished. So this is something that is very important. However, the other part that I mentioned that we wanted to integrate the sampler itself into mobile vectors as AUVs or gliders. This is something that we are now looking for partnerships. We have already some contacts and we are looking for partnerships to be able to have this joint development and application.
Okay, thank you very much. So we have one last question. If your presentation will be available, this I'm not sure, but at least the video will be available in our YouTube channel. So there you can find the presentation. So, well, thank you very much, Carmen. We don't have any other questions. I just want just to remind our audience that our next tech webinar of this marine observation series will be in July, and we will be focusing in the applications of our genomics observatory. So thank you again, Carmen, for your time and for this very interesting discussion. And good luck for all the developments of MicroSense in the future. I want to thank also Julia Santi, who helped us in the organization and back end of this webinar. So thank everyone for your participation, and looking forward to see you again in the next webinar.
Okay, thank you all.
Ciao.
See you, and don't hesitate to contact me.
Thank you.
Bye-bye. Bye, Julia.